and W2 are the subspaces of 4-dimensional vector space, which is defined as these two. Then we need to find the basis and dimension of W1, W2, their intersection, and also the sum of the subspaces. We need to find the basis and dimension both. So first, let's find the dimension for W1. W1 is defined to be as all those vectors such that B plus C plus D is equal to 0. So let's take this equation that B plus C plus D is equal to 0 and mark this as 1. Now since 1 is a system of one linear equation in 4 variables, that is A, B, C, D, right? So number of free variables is equal to, what is the formula for that? The number of variables, that is 4, minus the number of equations, that is only 1. So which is equal to 3. So we are having the number of free variables to be equal to 3. Now which free variables we need to choose? In this equation, A is not there, right? So let's choose A, and also along with A we are choosing B and C. So we have chosen the free variables to be A, B and C. Now we need to give them some values, and according to that we need to find the value for fourth variable, that is D, right? So how to give them the values? As these are 3 in number, so let's write the format of 3 by 3 identity matrix over here. So 1 0 0 0 1 0 0 0 1. This is the format for giving the values to A, B and C, which means we are giving value A to be 1 and B to be 0 and C to be 0 first. So for A equal to 1, B equal to 0 and C equal to 0, from this equation 1 we are getting the value of D to be 0. Then in the next set, we are giving the value of A to be as 0, B to be as 1 and C to be as 0. So for A equal to 0, B equal to 1, C equal to 0, we are getting the value for D to be, B is 1, so D is equal to negative 1. So this is negative 1. Similarly, for the third set, we are having 0, 0, 1. And for these values, the value of D comes out to be from this equation. Here C is 1 and B is 0. So the value of D is negative 1. So now let's write the basis for W1. From the first set, we are having the vector as 1, 0, 0, 0 because the vector is of the kind A, B, C, D. So we need to write first the value of A, then B, then C, then D, right? So the first vector is 1, 0, 0, 0 as the basis. And then from the second set, we are having 0, 1, 0, negative 1. And from this third set, we are having 0, 0, 1, negative 1. So these forms the basis for the subspace W1. And the dimension of W1 is the number of elements present in the basis. So it is 3. So the dimension of W1 is 3. Let's move on to the second subspace, that is W2. And the condition given to us that all those vectors such that A plus B equal to 0 and C equal to 2D. I can write this subspace again as all those vectors such that A plus B is equal to 0 and C minus 2D is equal to 0 for A, B, C, D belonging to the set of real numbers. And let's take these two equations now. So it is a system of two linear equations in 4 variables. So the number of free variables is equal to the number of variables minus the number of equations. So that is, we are having the number of free variables to be equal to 2. Now we always try to choose those free variables whose coefficient is not equal to 1. So here I can take D, and other variables are having the coefficient 1, 1, 1. So that doesn't matter, you can choose any of these. So I am taking A. So now we need to give the values to these variables so that we can find the value of other variables as C and B. For that, just write the identity matrix of 2 by 2 form. So it is 1, 0, 0, 1. That means first A is taking the value 1 and D is taking the value 0. And on the basis of this, from these two equations, we find the value of B and C. So for A equal to 1 and D equal to 0, finding the values of B and C. So in the first equation, for A to be equal to 0, we get the value of B to be as 0. So this is 0. From the second equation, we have given the value D to be as 0. So C is taking the value 0. Right. And now for A equal to 0 and D equal to 1. for A equal to 0, B is taking the value 0, right? And for D equal to 1, C is getting the value 2. So these are the set of values from which we write the bases. What is the format for the elements for the bases? It is A, B, C, D, right? So first we have to write the value of A for the bases. So that is 1 from the first set. 1, 0, 0 and this 0, right? From the second set, A is 0, B is 0, C is 2 and D is 1. So these are the bases we are getting for subspace W2, and the dimension of W2 is equal to the number of elements present in the bases, so it is 2. And now moving on to the intersections of the subspaces, right? We are having these two subspaces with the given conditions, right? So for the intersections of these two subspaces, we must write the conditions as all those vectors such that B plus C plus D is equal to 0, A plus B is equal to 0 and C minus 2D is equal to 0. So let's write all these equations. That is B plus C plus D equal to 0, A plus B is equal to 0 and C minus 2D is equal to 0. So let's mark this as 3. This is a system of 3 linear equations in 4 variables, right? So the number of free variables is equal to the number of variables minus the number of linear equations, that is 3. So this is equal to 1, and the number of free variables we need to choose is only 1. So always we need to choose that free variable whose coefficient is not equal to 1. So here I am choosing D and just give the value D to be equal to 1. Simple. And to find the value of ABC then, so for D equal to 1, from the first equation we get B plus C as -1. From the second equation we are getting A plus B to be equal to 0. From the third equation we get C is equal to 2. So as C is equal to 2, then again from this equation we get the value of B to be as -3, and then from the second equation we get the value of A to be as 3. So for D equal to 1, we are getting C as 2, B as -3 and A is equal to 3. So the basis is having only the one element, that is of the kind A, B, C, D. So writing first the value of A, that is 3, then the value of B, then the value of C, then the value of D. So this is the only basis we are getting for the intersection of the subspaces, right? So the dimension is 1 because we are having only the one element present in the basis. And at last we need to get the dimension for the sum of the subspaces. For that we are having one formula. So the dimension of the sum of the subspaces is equal to the dimension of W1 plus dimension of W2 minus the dimension of their intersection. And we have already found all these three in the previous parts. So the dimension of W1 we have found is 3 and the dimension of W2 is 2. Just now we have found the dimension of the intersection of the subspaces to be equal to 1. So we get 3 plus 2, 5 minus 1, 4. So the dimension of the sum of the subspaces is 4. So the dimension here is 4. Alright, thank you.